NASA's exploration of Mars has long fascinated people around the world. Through a series of groundbreaking missions, we've gained not only new scientific insights but also a deeper connection to the red planet and its potential to host life. Major breakthrough came with the arrival of the Perseverance rover in February 2021, packed with advanced technology. It delivered some of the clearest, most detailed images of Mars in 4K resolution, showing breathtaking views of its rocky, ancient surface and offering glimpses into its mysterious history, following in the footsteps of earlier missions like Curiosity. Perseverance is focused on understanding Mars' geology and searching for signs of ancient microbial life. Its landing site, the Jezero crater, was carefully chosen because scientists believe it once held a massive lake over 3 billion years ago, making it an ideal location to search for life's traces. With its sophisticated instruments, Perseverance can examine rocks and soil in unmatched detail. These observations are not only visually stunning but packed with scientific data that help scientists piece together the environmental evolution of Mars and whether it could once have supported life. The motivation behind NASA's multi-billion-dollar investment in Mars stems from a fundamental question: are we alone in the universe? This inquiry has fueled increasingly daring missions, starting with the twin rovers Spirit and Opportunity. Launched in 2003, Spirit and Opportunity made history by finding signs that water once existed on Mars. They discovered formations like Blueberry's hematite spheres, which only form in the presence of water, evidence that Mars was once a wetter and potentially habitable place, though designed to last just 90 days. Opportunity stunned the world by operating for nearly 15 years. It traveled over 45 kilometers, sending back thousands of photos and measurements that continue to shape our understanding of Mars. Then came the Curiosity rover in 2012, which landed in Gale Crater, home to Mount Sharp, a mountain layered with sedimentary rock. These layers act like a time capsule, recording Mars' climate history. Curiosity's mission: to determine if Mars ever had the right conditions to support life. Curiosity was outfitted with a variety of instruments, including ChemCam, which uses lasers to analyze rock surfaces. This allowed scientists to identify the chemical makeup of the planet's surface and investigate its volcanic and watery past. It also studied the Martian atmosphere, measuring cosmic rays, solar radiation, and atmospheric loss, some important factors in understanding whether humans could one day survive there. Curiosity made landmark discoveries. It found clay minerals and ancient riverbeds, proof that liquid water once flowed on Mars. It also identified the 6 basic elements needed for life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. One of its most intriguing finds was methane in the Martian atmosphere. On Earth, methane often points to biological activity, though its presence on Mars could also be geological. Either way, it hints at dynamic processes still happening beneath the surface. Perseverance builds upon these findings and pushes the mission further. While Curiosity analyzes materials on site, Perseverance is collecting and storing rock and soil samples for a future mission to return them to Earth, a feat never before accomplished. This planned sample return, in partnership with the European Space Agency, could allow scientists to study Martian material using the full capabilities of Earth's labs, revealing details that rovers simply can't detect. But in March 2021, Perseverance took its first drive across Jezero crater, beginning a mission that would quickly reshape how we explore planets. It has since uncovered strange rock formations nicknamed leopard spots, which may hold clues about Mars' ancient climate. Beyond the science, Perseverance has become a symbol of hope. Over 10 million people sent their names to Mars, etched on a chip aboard the rover. A plaque honored healthcare workers during the COVID-19 pandemic, and a hidden parachute message boldly declared, "Dare mighty things." The rover's cameras have captured unforgettable moments, like its descent onto Mars and the Octavia E. Butler landing photo. Panoramic views and surface-level images from its hazard avoidance cameras bring the Martian world closer than ever before. One image from Sol 213 even showed the discarded parachute and back shell, lying 2 kilometers away, reminders of the rover's dramatic arrival. A major highlight of this mission is its collaboration with the Ingenuity helicopter. In April 2021, Ingenuity became the first aircraft to achieve powered flight on another planet, a milestone compared to the Wright brothers' flight on Earth. Since then, Ingenuity has flown dozens of times, taking aerial images and recording sound from Mars. One flight even snapped a picture of Perseverance from above, giving a unique view of the rover at work. These two machines offer complementary perspectives: Perseverance from the ground and Ingenuity from the air, helping scientists better understand Mars terrain and find areas worth exploring. Together, they are setting the stage for human missions. The data they collect on radiation, surface conditions, and resources will be vital for future astronauts who may one day walk on Mars. Perseverance is more than just a scientific tool. It's a marvel of engineering and international teamwork. It continues a journey started by Spirit, Opportunity, and Curiosity, each of which revealed Mars to be more dynamic than we ever imagined. Curiosity's work on Mars' lost magnetic field and thinning atmosphere has helped us understand why the planet turned cold and dry, findings that are also useful in searching for habitable worlds beyond Earth. Methane continues to be one of the most intriguing and unresolved puzzles on Mars. On Earth, methane is commonly associated with biological activity, often produced by living organisms. However, it can also be generated through non-biological processes such as volcanic activity or chemical reactions between rocks and water. The detection of fluctuating methane levels in the Martian atmosphere has raised compelling questions. Is the methane a byproduct of microbial life hidden beneath the surface, or is it the result of geological processes occurring deep within the planet's crust? Unfortunately, the Curiosity and Perseverance rovers lack the tools needed to definitively determine the source of the gas. Still, their ongoing observations, particularly of when and where methane levels spike, are building a valuable data set that may eventually reveal the answer. The mystery of Martian methane remains one of the most promising leads in the search for extraterrestrial life. Yet the mission of Perseverance goes far beyond solving scientific riddles. The rover stands as a powerful symbol of human ingenuity, resilience, and our collective yearning to reach beyond the confines of our world. In many ways, Perseverance represents the best of what humanity can achieve when driven by curiosity and collaboration. It embodies our willingness to take bold risks, to tackle the unknown, and to pursue knowledge not for immediate gain, but for the advancement of future generations. More than just a scientific instrument, Perseverance is a story of perseverance itself. Its journey from concept to launch spanned decades of engineering trials, mission design, and international cooperation. Every wire, camera, and instrument aboard the rover is the result of tireless work by countless scientists, engineers, and visionaries who dedicated years to making this mission possible. The name Perseverance was chosen not just as a label, but as a tribute to the spirit that carried the project, through obstacles and setbacks to eventual success. As it rolls across the Martian landscape, Perseverance is not just gathering data, it's writing the next chapter of human exploration. Its wheels leave tracks not only on Martian soil, but in the history of space science. It reminds us that our place in the cosmos is still being discovered, and that the story of Mars and of ourselves is far from over, but it doesn't stand alone. Its work is part of a long-term international effort, which includes future missions to retrieve its samples. Likely in the late 2020s or early 2030s, a Mars ascent vehicle and a fetch rover will work together to send those samples into orbit, where another spacecraft will collect them and return them to Earth. If the Mars sample return mission succeeds, it will represent one of the most groundbreaking achievements in the history of space exploration, a monumental first, the return of physical material from another planet. While we've previously brought back lunar rocks from the moon and samples from asteroids, retrieving samples from Mars would mark the first time in human history that material from a planet other than Earth has been physically brought home for study. This ambitious mission, jointly planned by NASA and the European Space Agency (ESA), is poised to revolutionize our understanding of the Red Planet and possibly reshape our view of life in the universe. The samples collected by the Perseverance rover are being stored in titanium tubes and carefully sealed to preserve their integrity. These rock and soil samples were chosen from diverse locations across the Jezero crater, a site believed to have once hosted a large long-standing lake. This environment, complete with an inflow and outflow system, makes it a prime candidate for finding signs of ancient microbial life. Scientists hope that locked within these Martian rocks are the secrets to the planet's watery past and, perhaps, the remains of microscopic organisms that may have once thrived there. Once the samples are returned to Earth, researchers will be able to study them using laboratory instruments far more advanced than anything currently on board a Mars rover. On Earth, scientists will have access to tools like high-resolution electron microscopes, mass spectrometers, and isotope ratio analyzers, capable of detecting the faintest traces of organic compounds or fossilized microbial structures. They will be searching for subtle chemical fingerprints, microfossils, or mineral formations that could only have formed in the presence of biological processes. These analyses could provide the strongest evidence yet that Mars was once home to life, even if only in its most primitive form. Beyond the search for life, the returned samples will also shed light on Mars' geological and climatic history. Scientists will be able to determine how long liquid water persisted on the surface, how the planet's magnetic field and atmosphere eroded over time, and how internal processes like volcanism and tectonics shaped the Martian landscape. This information is not only crucial to understanding Mars as a world, but also helps inform how planets form, evolve, and possibly become habitable. This mission has been widely compared to the Apollo moon landings in terms of its potential impact. Just as Apollo fundamentally transformed our knowledge of the moon and inspired generations to look toward the stars, the Mars sample return could redefine our understanding of life itself. If even a single biosignature is found, whether chemical, isotopic, or structural, it would indicate that life is not unique to Earth. It would suggest that life could emerge naturally wherever the conditions are right. dramatically increasing the chances that we are not alone in the universe. Such a discovery would be one of the most profound in human history, altering not only science, but philosophy, religion, and our place in the cosmos. This idea would reshape our understanding of biology, evolution, and the universe itself. It would suggest that life is a natural outcome of planetary processes, not a rare accident. Preparing for human travel to Mars is another major benefit of these missions. NASA's Artemis program, which plans to return humans to the moon, is seen as a stepping stone. Technologies being tested on the moon, from landers to life support systems, will be critical for future Mars missions. Data from Perseverance about Martian dust, terrain, radiation, and weather are already helping engineers design safer missions for astronauts. Inspiration is another powerful outcome. These missions don't just fuel science, they ignite imagination. From classrooms to art studios, the images and discoveries from Mars inspire people worldwide. Ingenuity, originally seen as a small demo, has outperformed expectations and proven that flying on other planets is possible. Future missions will likely include more drones, giving scientists the ability to scout larger areas quickly, with Perseverance leading the way. NASA is pushing the boundaries of what's possible. Its wheels are carving a path not only through Jezero Crater, but through the future of space exploration. Its legacy may not be one discovery, but the foundation it lays for humanity's future among the stars. Each image, each drill sample, and each signal it sends brings us closer to answering the questions that have echoed through time. Are we alone? Could we one day live beyond Earth? What can Mars reveal about our own planet's history and fragility? Perhaps the answers lie not in far-off galaxies, but in the dust of our planetary neighbor, being studied right now by a six-wheeled robot carrying humanity's hopes across a silent red world.